Hey friends, welcome back. Checkpoint 3. Cloud Technology and Services Retrieval Challenge is one of those topics where a single qualifier word changes the answer. Today we'll see exactly why. Let's get into it. By the end of this video, you'll be able to take a 5-line scenario and snap it to exactly one right service, fast. The technology domain is the largest single slice of the Cloud Practitioner exam, and its most common question shape is simple to describe and surprisingly easy to fumble. Here's a workload. Pick the right service. You've just worked through 12 dense videos on compute, storage, databases, networking, and management. This checkpoint runs 5 scenarios that mirror those questions, with no new material at all. Over the last stretch of this series, you covered a lot of ground. Compute, from EC2 through Lambda and Fargate. Storage, from S3 storage classes through EBS and the Snow family. Databases, networking, and the management services that watch over all of it. Knowing a service exists is one thing. Pulling the right one out of memory when 4 plausible options sit side by side is the skill that actually moves your score. That's what these 5 scenarios test. Here's how each round runs. I'll lay out a scenario the way the exam would, with a small set of plausible options. Then you get a moment to pause and commit to an answer before I reveal anything. From there, we walk through the distractors and knock them out one by one, using the qualifier that disqualifies them. And finally we land on the answer with a single short reason. Each round is a representative pick the right service question. This is pure retrieval practice, so nothing here is new. If a service feels unfamiliar, that's your signal for what to review. The whole method comes down to one habit. Don't hunt for the best answer first, because every option is designed to look reasonable. Instead, find the disqualifying keyword and remove everything that violates it. A 15-minute cap rules out Lambda. The word containers rules out a plain virtual machine. Once the violators are gone, the survivor is usually obvious. Strong test takers do this almost automatically, and it saves you real time on every scenario question. 5 scenarios, 1 shape, 5 different corners of the technology domain. First, pick the compute service for a workload. Second, pick the right S3 storage class. Third, pick the edge service. Fourth, pick the management service for an audit question. And fifth, pick the database. Same exercise every time. Read the scenario, find the qualifier, eliminate, commit. Let's start with compute. Scenario 1. A logistics client receives shipping documents at unpredictable, irregular times. Sometimes a burst, sometimes nothing for hours. Each document needs to be processed with sub-second response. There's no steady stream of traffic between arrivals to justify keeping servers running. The candidates are Lambda, EC2, Fargate, and Elastic Beanstalk. Pause here and pick the one that fits before I break it down. Let's eliminate. EC2 is tempting because it's compute, but with sporadic arrivals you'd pay for idle capacity the whole time nothing's happening. So it goes. Fargate is the serverless container option, but the scenario never mentions containers, so there's nothing to run on it. Elastic Beanstalk provisions an always-on web stack, which is overkill for an event that fires now and then. Now look at what survives. The work is event-driven, with a trigger firing per document. It's short-lived, well under any 15-minute limit, and it should scale from 0 and bill only while running. That's a precise description of one service. The answer is Amazon Web Services Lambda. Wire an S3 upload event to a function, and each document is processed the instant it lands, with no fleet of idle servers waiting in between. Think of Lambda like a motion sensor light, off and costing nothing until someone walks in, then on in an instant. The pairing of sporadic plus sub-second is the green light every time. Scenario 2. And now we're picking a storage class. A client must retain records for 7 years to satisfy a compliance mandate. The data is touched at most once a year, Often not even that. The instruction from the business is the lowest possible storage cost, and critically, a multi-hour wait on the rare occasion someone needs the data is perfectly acceptable. Pause and pick your S3 storage class. Time to eliminate. Standard IA is built for data you reach infrequently but still need back instantly, and you'd pay for that speed you don't need. Glacier Instant Retrieval has the same problem, paying a premium for millisecond access on data you touch once a year. Glacier Flexible Retrieval is genuinely cheap, but there's a class cheaper still. What survives is the option with the lowest cost of any S3 class, built explicitly for data accessed less than once a year. Its 180-day minimum storage duration sounds like a catch, but for a 7-year hold it's irrelevant. The answer is S3 Glacier Deep Archive. Picture the deep storage salt mine where companies send tax records, dirt cheap to keep for years, but you file a request and wait a day for someone to dig the box out. At roughly $1 per terabyte per month, it's about 23 times cheaper than standard, and you give up nothing on safety. Every Glacier class carries the same 11 nines of durability as standard. You trade retrieval speed for cost, not data protection. And notice how closely the scenario tracks the official description. Amazon Web Services' own storage classes page says Deep Archive delivers the lowest cost storage for long-lived archive data that is accessed less than once per year and is retrieved asynchronously. That phrase, accessed less than once per year, is almost word for word what the scenario handed you. When the question echoes the marketing one-liner like this, the answer is usually sitting right there in the wording. Scenario 3. A multiplayer gaming backend needs static IP addresses to give clients a fixed entry point. It demands the lowest TCP latency to the nearest healthy endpoint, because in real-time gaming every millisecond of jitter is felt, and the traffic is real-time game packets, so there is nothing to cache. The options are CloudFront, Global Accelerator, and Route 53. Pause and choose your edge service. Let's eliminate. Start with caching. Real-time game packets have nothing to cache, so any caching layer adds nothing here. That rules out Route 53 next, which handles DNS routing rather than fixed IP traffic acceleration, and it rules out CloudFront, a content delivery network for cacheable HTTP content with no static IPs for raw TCP. What survives is the service that gives you 2 static anycast IP addresses as a fixed entry point, routes raw TCP and UDP over the Amazon Web Services backbone to the nearest healthy endpoint, and fails over instantly when an endpoint goes unhealthy. The queue is the requirement for static IPs and raw transport rather than cacheable content. The answer is Amazon Web Services Global Accelerator. Here's the clean separation. CloudFront is a chain of neighborhood libraries keeping copies of popular content near you. Global Accelerator is a private express highway with 2 fixed on-ramps that moves your live packets to the nearest open warehouse fastest. When there's nothing to cache, only real-time traffic to move, and you see the words static IP plus lowest TCP latency together, that pairing points to Global Accelerator. Again, the documentation hands you the answer. Amazon Web Services says Global Accelerator uses the congestion-free Amazon Web Services global network to route TCP and UDP traffic to a healthy application endpoint in the closest region to the user, with instant failover to the next best endpoint. TCP and UDP, closest endpoint, instant failover. Match those phrases against the scenario and there's no contest. Scenario 4. A production EC2 instance was terminated last Tuesday, and nobody owned up to it. The team needs to know who did it, from what IP address, and exactly when. This is an accountability question, not a performance question, and that distinction is everything. The candidates are CloudWatch, Amazon Web Services Config, and CloudTrail. Pause and decide which service answers it. Eliminate on the qualifier. CloudWatch answers how is it performing, with metrics, alarms, and dashboards. It never tells you who pressed the button, so it's gone. Amazon Web Services config tracks how a resource was configured over time, which is great for compliance drift, but it doesn't name the actor either. Neither one records the identity behind an API call. What survives records every API action as an event, capturing user identity, source IP, and timestamp, and the terminate instance's call shows up right there in the event history. The answer is Amazon Web Services CloudTrail. Think of it as the building's sign-in log and security camera. It doesn't care whether the lights are too bright, that's CloudWatch's job. It records who badged in, when, and which door they opened. 2 caveats worth holding onto. CloudTrail won't capture a shutdown triggered from inside the operating system, and the free event history only reaches back 90 days. For anything older, you'd need a trail delivering to S3. The phrase "who did what" always points to CloudTrail. Last one. Scenario 5, and we're picking a database. The application needs single-digit millisecond reads and writes. The data model is NoSQL key value, not relational, and it has to scale to massive volume with no servers for the team to provision or manage. The options are RDS, Aurora, Elasticache, and DynamoDB. Pause and lock in your pick. Eliminate. RDS and Aurora are relational engines, and the scenario explicitly says NoSQL, so both are out on the data model alone. Elasticache is an in-memory cache that sits in front of a database. It's fast, but it isn't a durable primary store, so it can't be the system of record. What survives is serverless, fully managed NoSQL, delivering single-digit millisecond performance at any scale, with a key value and document model and automatic scaling. That's one service and one service only. The answer is Amazon DynamoDB. Picture a code check counter that never grows a line, whether 10 people show up or 10 million. Hand over your ticket, get your item back in milliseconds, with no counter staff for you to hire. That's not marketing fluff either. DynamoDB handles more than 10 trillion requests a day and has peaked above 20 million requests per second. The qualifiers serverless, single-digit millisecond, NoSQL, and massive scale together name exactly one database. Here's all 5 mapped at a glance. Sporadic plus sub-second goes to Lambda. Once a year plus lowest cost goes to Glacier Deep Archive. Static IP plus lowest TCP latency goes to Global Accelerator. Who did what goes to CloudTrail. And serverless single-digit millisecond NoSQL goes to DynamoDB. The line at the bottom is the whole skill. Read the qualifier before you read the options. The qualifier is the answer key. Let's lock in what carries forward. The disqualifying keyword does more work than your best fit instinct, so train yourself to find it first. The distractors are plausible by design. When all the compute options are compute, you can't lean on category alone. Eliminate on the constraint instead. Containers means Fargate. Continuous means EC2. Who did what is always CloudTrail, while performance is always CloudWatch. And for storage cost, remember slower retrieval means cheaper storage, so reach for deep archive only when a wait is acceptable. Now let's see how well you absorbed all of this with a quick 5-question quiz. Alright, time to put your knowledge to the test. Question 1. A startup runs a backend job that fires only when a user uploads a file to S3. Uploads are rare and irregular. Each job finishes in under 2 seconds, and the team wants to pay nothing when nothing arrives. Is it A, an EC2 instance kept running? B, a Fargate container task? C, Amazon Web Services Lambda triggered by the S3 event? Or D, an elastic beanstalk web environment? Lock in your answer before I give it away. This one is C, Amazon Web Services Lambda. Rare irregular triggers plus a sub-second task is the event-driven, scale from 0, pay only when running signature. EC2 and Beanstalk bill you while idle, and there are no containers here for Fargate to run. Question 2. A hospital must keep imaging records for 10 years for compliance. The data is almost never read. A several-hour retrieval wait is fine. And the goal is the absolute lowest storage cost. Is it A. S3 Glacier Deep Archive, B. S3 Standard IA, C. S3 Glacier Instant Retrieval, or D. S3 Glacier Flexible Retrieval? Pause here if you want more time. The right call here is A. S3 Glacier Deep Archive. Long retention, access less than once a year, lowest cost, and a tolerable multi-hour wait is its exact profile. Every other option charges more for faster or more frequent access you don't need. Question 3. A real-time multiplayer game needs a fixed pair of static IP addresses and the lowest possible TCP latency, routing players to the nearest healthy regional endpoint. Nothing is cacheable. Is it A. Amazon CloudFront, B. Route 53 with latency routing, C. Amazon Web Services Global Accelerator, or D. An application load balancer? Got your pick? Let's see. It has to be C. Amazon Web Services Global Accelerator, and here's why. Static IPs plus lowest TCP latency to the nearest healthy endpoint, with nothing to cache, is its exact signature. CloudFront caches HTTP and gives no static IPs for raw TCP, and Route 53 only resolves DNS rather than accelerating the traffic itself. Question 4. A callback to the EC2 Fundamentals episode. An administrator wants an auto-scaling group to launch every instance from the same version definition of AMI, instance type, security group, and IAM role. Which component should the group reference? Is it A. a launch configuration, B. a launch template, C. an Amazon machine image on its own, or D. a cloud formation stack? Think about which one is versioned. If you said B, well done. The launch template is the versioned configuration document that bundles the AMI, instance type, security group, and IAM role. The launch configuration is its deprecated, non-versioned predecessor, and newer accounts can't even create one. Last question. An application needs a fully managed, serverless key value store, with consistent single-digit millisecond reads and writes, that scales to millions of requests per second with no servers to provision. Is it A. Amazon RDS for PostgreSQL, B. Amazon ElastiCache for Redis, C. Amazon Aurora, or D. Amazon DynamoDB? Run the decision rule from earlier before you answer. The answer is D. Amazon DynamoDB. Serverless, single-digit millisecond, NoSQL key value, and massive scale is its profile almost word for word. RDS and Aurora are relational, and ElastiCache is a cache that sits in front of a database, not a durable primary store. All right, that's checkpoint 3, Cloud Technology and Services Retrieval Challenge in the bag. Subscribe for the next episode of the Amazon Web Services, the Amazon Web Services Certified Cloud Practitioner Exam Mastery. Give the video a like if it helped, and I'll see you in the next lesson.